Um, what's this video about? This video is about ping pong with the Excel stepper library and 2 limit switches, polling and interrupts. Well, I would add debouncing to that title, which is quite clickbait actually, in its own curious how the internet works way. So well done, curious scientists, for making an excellent stepper motor video. My mind got taken off into the direction of robots playing ping pong because I wanted to make my video more entertaining. So coming up will be a discussion on the subjects of robot playing ping pong, which you can just do by typing.
So you, for example, have to switch the direction.
No, I'm not listening to him now. I want to just do a search for robots playing ping pong. It's taking long enough, isn't it? Right, we go down to table tennis trainer robot battery powered. That's quite interesting, but we will not be distracted. Here's a robot playing ping pong. My favourite is this one. The attitude of the robot. Oh, okay, we're going to play it from the beginning.
Ping pong added robots to their league.
The music's good, isn't it? He sends him right off into the corner. And then you get into a repeat mode, so you watch it again and again and again and again, and that's the nature of a short. Whereas the nature of a decent video on how to debounce an Arduino in a single direction might well be worth 30 minutes of your time. I'm Simon Masters from the Field of Study, where basically I'm installing some electronics, or I've rekindled my interest in electronics, and this was a piece of stuff which, in this piece, has got to go up into the shed. It's a dreadful day in terms of solar production today. Look at the weather. It's pouring with rain. No, it's not actually, it's just drizzling. What have we got going on here? Well, I'll take you straight into the shed rather than show you a 16 kilowatt solar array. We are fortunately not running on the Jenny today on the Field of Study. I'm getting 266 watts, looks like, on that side. What's this side looking like? It's charging and all the rest. So 6 kilowatts of hybrid inverter. Let's have a look at the battery levels. 8%. Let's see, that's not very good, is it? Moreover, after doing the total on this one, it will go to max min. Now that's reduced on that. That's the only battery I need to check here at the moment. I will plug this in and see whether or not it has any effect. It can only go in one way, up and down. Does this interest you, or am I being incredibly boring? Actually, it's got to go that way up, looks like. Yes, it does have to go that way up. Let's just work out on the detail of that then. So that sits that way, and that sits that way. Which is right, because negative is to my left, and positive is to my right on this battery. But I actually have no idea if there's any current passing through that device, and I haven't connected. Look at this shambles that somebody made at this end. That's not me actually, but even if it was, I would have to admit to it and say that it's in my possession now and I'm responsible for making it work. So that's the difference of the max min. Let's go through the individual cells. I think I can do that. I type, I do, and then we go cell. So the 25 volts, I didn't read it accurate enough. 3.5, 3.5, 3.6, 3.6 and a half, yes, 3.66, 3.7, 3.6, and altogether they add up to 25.34. Right. If I do that on this battery, I won't spare you the boredom of it, if you like. I would be able to tell if this, well, I will do it because this is why I'm what I do on a rainy day. So I put the phone down for a second, move the device onto the next 8-pin, I think it is, or 9-pin connector. I'll just give you that figure accurately. 8-pin connector, of course, because it's a 7-cell lithium battery. And here this battery is at I'm on the right type, am I? Yes, I'm on the right. I'm going through the cells individually. 24 altogether. I forgot what the other one said. 33, no, 3.378. So let's just read it as though it was 3.3. 50, 55, 44. No, 134, 158. All right, so there's a tenth of a volt difference between the cells at one end and the other there, and maybe, what was it, 2/10 of a difference on that cell. But principally, there's no, I have to admit, there's no battery management system on this. All right, I'm assuming that this device is not overcharging and all the rest. It's actually gone into an equalization mode, which is interesting because you can hardly equalize on 266 watts. I'll spare you all that boredom. Point is, I have to come out here in order to look at this, and the way things are going, all that becomes too much work and thought. I need to be able to just look at it on a computer and say, what is going on? Why is this all gone? White for a minute or two. It's time to go and sit down. Somewhere in here I had my meter, I think. I see it! Right, what am I actually doing with this meter right now? Let's strip off the wires and just have a quick look at amperages. But even this, you see, that's, if you do this a dozen times a day, even with this delightful device, it gets tedious. Right, that's set for 600 amps. I don't think we're going to be seeing that on this. 1.3 amps, all told out of the solar at this point in time. 2.1 amps coming back on the return. See, that should say the same. So I'm going to go into a different mode with this meter, which is varying at the moment. Is that normal? I've never had one of these. This one's supposed to talk to my phone. So I believe I press that button there, and that zeroes it. If I move it around, not very much. I could put it around a cable that's in AC mode and read that. But let's assume for a minute before we go into this power consumption meter. See, it's in thin air. It shouldn't be reading anything at all. And it's in... Right, it's lit up now. Can you see that better than I can see it? Because if I can't see it on my phone properly, so that might be good discipline with video making, to be able to see very clearly what amps you're reading. Right, it's in DC mode and it occasionally flutters. And when it flutters, what does it do? Well, I think if I do a hold, I think that's equivalent to a reading. Right, I'm going to try it now on here. Oh, put it around one cable. Where am I looking? Up here. It's somehow the light's turned off. Would help if I took that piece of bloody paper off. That's got to be better, isn't it? So in these grey conditions, this set of panels is producing minus 0.6 amps on that side and plus 2.2 on that side. Let's do it again. And you see, here we have one of the fundamental problems, right? I'm measuring now accurate to 1 decimal place of 1 amp, possibly. But I reckon the outside light conditions could have changed somewhat. So that's saying 0.2 of an amp, and that's saying 1.1. And frankly, I think that's within the realms of the accuracy of this device, using it the way I'm using it, unless I can find a more clever way of using it. It is a clever device that it will actually send a Bluetooth signal to my telephone, and I could read those figures out. Now, another figure I'm interested in reading then is the amperage on this side. Let's see what this one says. Notice I'm putting this through these cables in a particular, the same way every time, because negative amps means the current flows the other way. So this device, which is a hybrid solar charge controller, is charging batteries at 48 volts, round about 48 volts, at between 2 amps, 2.5 amps, and 0. I don't see it going into the negative very often. So now I'm gonna, for want of proving a point, perhaps, to myself, let's do the hold thing first. That doesn't seem to hold very much at all, does it? Now I think it's quite conceivable that the device above is altering the amperage on a second by second or even sub-second by sub-second moment, because certainly if the sun came out, that amperage in that current, in that cable, would increase substantially. Well, for example, what limit switches have I got on here? No, not limit switches. I've got 32, 32, 32 and 32. Only 3 of them in use. This produces, I forget, 80 amps? It'll all be on there. 165 watts coming in. We're barely above background consumption here, frankly, today. But there's petrol in, so there's not going to be a failure of electricity. Now, I'm supposed to be charging the battery in my car, or worse still, I'm supposed to be putting that battery into my car, so I need to measure the voltage of that battery. Black in the middle for common and red on the outside. Switch this to voltage. Right, there we go. So as I am waving this in front of the machine, it is reading out figures like 1.3, 5 point, but they're all in millivolts. Alright? So although this is not in contact with anything, the ambient air and everything is conspiring to make this hover about the millivolt level. I'm going to put that one on the positive end, and I'm going to put this one on the negative end, and then we're going to take a reading. 12.04. I could go and just show you that probably. Right, and now because it's jumped from milliamps, which are too small to be shown, into amp mode, right, that is now saying 12.04 volts. Have I been talking amps, by the way, all the way along here? My mistake. Anyway, the point is I got a 12.5 volt, no, 12 point, Naught for. That's not even worth swapping out into my car. If... Right. That's at 12 volts, 12.0 to all intents. Now let's check the battery in the car, which is failing to start the car. And most frustrating that is on a day where I had nothing better to do than go and pick up a 2 horsepower BLDC motor. 2 horsepower, 2 kilowatts. That's more than horsepower. Right. Wending my way through the Japanese garden on a wet afternoon. He drops the phone and the keys and the meter in the mud. No, success. There's the spanners if I want to take the battery out. Right, let's put that in there and not turn it on, and let's open the bonnet. Taking the meter with you. That one up there is 12 volts. If this one is above 11.5, it's hardly worth swapping out. Is that going to be your rule? Where's the thing? Patience is a virtue. Possess it if you can. It's seldom found in women and never in a man, because look at that, I got to juggle the meter into the middle, a prop into the hole, and then we can see the battery. So, bit of a rat's nest for wiring. You got no points for that, but basically these don't do anything to do with the starter, that's for sure, or the charging, because that comes in on more serious circuitry. Now then, red to red and black to black, and we're still on voltage management because we were in voltage reading on the far end. 12.6. See, so I would be in a worse situation if I put the 12 volt battery in there, that's for sure. So we're not swapping batteries. Good, I've saved myself a lot of work. Now I can jump start this car with another one like it, same size so to speak. If I connect red to red and black to black, I should be away, and there's several wires in the back of this car for that very purpose, except they are absolutely useless. Jeepers creepers, I've never really let things get to a stage like this before, but look at the state of them. I think I need a black one and a red one, and I need to examine why I haven't got the right connector on one end of them, I think. No, there's 4 connectors. Not confirmed yet. Yes! Alright. So we take them indoors and have a look at them and give them a brush up and make sure that they get a bit sparkly. Shall we do that? Turn the meter off so you don't drain the battery out the meter. Leave the meter in the car, shut the bonnet because you don't want any damp getting in. Right, your other job, given that that was there, was to find the fuses and find out where the leakage overnight is going to, because maybe I didn't take it for far enough of a drive after. But this is a 12.6 volt battery, and this is what he sounds like when he starts. I'll do that actually in a minute. What I'm looking for, of course, is the wires that take the, well, okay, so first of all I can see that if a fuse is blown, it's not the cause of a power drain overnight, so to speak, because the fuse breaks the circuit. But it occurs to me that if any of those fuses there have got any current running through them, current, even at 0.1 of an amp, I might drain the battery sufficient to have not recharged it. Normally if my battery is tiresome, I can just take it for a short drive and it charges up. I don't think the problem is on the charge circuit in this vehicle, but I can find that out if I can find where the wires come up from the alternator, which is where then? Not very accessible, because this just disappears down underneath the car. Well, I had these off and cleaned up yesterday, and that one, which was potentially not good, is quite firm under my fingers at the moment. There's no... And what have we tested this at? 12.6. See, you could argue that if the car now starts, it was just to get me in a state. But I don't think it's going to start. There's no way this car's going to start, because it hadn't started this morning. Right, I depress the clutch. It's a diesel, so we wait for that light to go out. There's a fan on. Turn the fan off. Lights are off. Oh, geez, do you hear that? Relay, connection to starter. I do believe we've got further along. It's facing downhill. Do I want to push it downhill? No way do I want to push it downhill. I don't think it'll even roll under its own steam. No. We wait till Harry comes back, we put the jump leads on, I clean them up, and I've done more diagnosis on that. But what I can do is turn the ignition off, so I'm not using any power inside. That includes shutting the doors. Look, the door's open and there's no courtesy lights coming on. This door's open, there's no courtesy lights coming on. I don't think there's any lights in behind here that come on, even if they do in the best of times. So that's not happening. Or should I have had the ignition on when I did all those things? Is there a light in here that comes on when the ignition's on? Yes, but I left it on. It wasn't as though I left the ignition on overnight. I took the keys with me. Right, just going through all of that shite in your own head makes some sense. Right, take the keys out. This is the condition in which the vehicle was left. Now, given that the vehicle is in a state of 12.6 volts in its front battery, there's no point in swapping it for a 12 volt battery that's in the shed. Neither is, for that matter, any point in trying to jump start it with that same battery, which is something I would have done without this meter. Right, let's get this one into amps mode. Right, that means moving that dial to that position, and just doing it in the wet and the rain, I couldn't actually move it. Can you believe that? Right, here I am doing a meter testing thing. No idea if this is going to come out any good or not. The meter is not in amp mode. I want to put it in amp mode, which means moving that into that position, and at this level looks like I can measure 0.1 of an amp. So if any of these fuses, I should test continuity first just to see I'm hitting the fuses in the right way, because there's example fuses here where I got to take the top off in order to bloody read them. What is that about? Can I take the top off of that? No. Is there external contacts? Well, you see, that's why you've got to set it in a different mode first. You've got to put it in a mode like this, where that's it, milliohms. milliohms alarm. So you have to move the select button onto alarm. No. Okay, in order to do that, the red has to be on that side. Oh, look at that. Right, that's me just touching the two together like that. So as a general rule on automotive fuses, fuses have got a contact at either end that's exposed. There you go, did you hear it? I hit the two places either end of the fuse, and now it refuses to do it again, which is either because I've got the tips dirty or I didn't get a very good contact. So, right. The fact that you can hear anything at all means the fuse is intact. So in that way it's very quick to run through a bank of fuses. Very quick. The only quicker way of doing it is if you can actually see the fuses, and of course in this way these are plugged in. I will show you what I'm talking about. These fuses here, I've just tested that little lot by pressing up against, doesn't matter which way around you do it, black or red, you just have to be on the same fuse, and if you hear the thing once, the fuse is okay. Now, what I want to do is see if any wires I can pick up an obvious drain. That's a different test. Test that I have not had the capability to do before because I've not had a clamp-on meter before. This meter talks to my phone. I can't believe the fact that this meter talks to my phone. Right, so now we're moving into a different setting. I think I'm supposed to take these out. Anyway, it's nice to just not have them for a minute dangling around. Goes on to the amperage meter, the amperage metering, and according to this it comes up at minus 1.4 in thin air. I have before pressed the REL button, whatever that means, which is I think release might be, or it might be, right, excuse me while I read my meter for a minute. It's in DC mode, it's Bluetooth is enabled, it's got a triangle which I do not know what that means, so I'm going to change to select mode. Now it's gone into AC, now it's gone into DC, and the triangle has disappeared. So if the triangle's disappeared and a value of minus 1.5 amps has appeared, I wish to zero it because 1.5 amps overnight could be enough to reduce the charge on this battery. Mind you, because I'm not thinking straight, I thought 15 or 20 minutes ago I actually identified that it was a connection with the starter motor, because there's voltage in the battery, and see, that is showing 0.7 of an amp, and the triangle's back. 0.7 amps hold. The light came on. Short hold. DH. What does that mean? Don't know. If I now press max min, No, it doesn't have any effect. The hold is off now. 0.8 of an amp. Right, is it possible that this red wire goes to the starter motor relay? No, wait a minute. That does make no sense whatsoever. First of all, these red wires are not about that. These red wires are about something else. They look completely like somebody's introduced them amateur-wise after the event. They go in here, and besides which, one of them comes up here and does absolutely nothing. This one here. Let's do the diagnostic from the point of view of what actually is at fault. The battery is not at fault. The battery is not at fault. What seems to be taking place now is that there's not enough voltage to engage the starter motor direct to earth full, you know, the relay. Yeah, did you hear what I mean? It's like it's trying to sneak in to hold the relay in. I could come down here with a battery that's over 12.7 volts. Let's just do that last meter reading. The last meter reading with the meter and the wires. Now you could say to yourself, should all this be done in silence? You go into sort of a zone or into an autopilot and say, that's a silly thing because I haven't put it round to volts. See, if you had 2 meters, one on volts and one on amps, you wouldn't have to worry that you were doing it wrong. 12.06 volts. Shut the bonnet. Don't get your fingers in. Take the keys out the ignition, but it wasn't turned on. Reflect on what you have just seen and done. I didn't realise I had a pair of battery cables quite as good as these, not fully intact. This set's not particularly long. There's a nice set in there actually. I should have my battery jump leads a bit. Let's dry them out. Keep them dry. Not in a damp environment. Don't let water get into the cables. Don't let water get into the cables. This was meant to be a short, wasn't it, Foxy? Are you guarding this solar charge controller that you knocked off just now? Pulse width modulated, that one is. Pulse width modulated, Foxy. Do you have a clue what that means? You want to play with the electrics, do you? You want to be in the video. Alright, that's the end of me for this afternoon.